Okay, guys. So our next topic is security capability of systems. Right now, system you understood well, right? We have so many different type of systems. It can be a hardware system. It can be a software system. It can be something as a middleware or some kind of firmware, right? Where does this all system, right? Let it be a standalone system. Let it be a standalone system. Let it be a client server architecture system. Let it be a distributed system. Let it be a database system, right? Where all these systems are hosted? They are hosted on which layer? That is your operating system, right? So operating system itself is a system, right? And where does this operating system lies? It sits on top. It sits on top of what? It sits on top of hardware system. If there are vulnerabilities in the hardware by itself, it is going to impact the operating system, and the operating system will then further impact your all these different type of systems which you are making on top of it. Agree with me or not? Agree, right?
Yes.
So when we say protection, what we are going to protect end of the day, because all this data, all this application is all based on processing of information, right? All the systems are processing information, and we know, right? In a particular system, let's take it from a hardware perspective first, right? Where does the data lies, right? In a particular system, let's talk about inside a particular computer system. Let it be a laptop, or maybe a desktop, or may it be a server, right? Where does the data host? So data is at rest, data in motion, we can say, or data can be in use. Agree with me? When we say data at rest, where the data is residing, it may be based on your hard drive, it may be based on your random access memory, right? Or it may be on a system which is attached with your system, maybe an external drive, but it is all data at rest, right? When we say data in motion within a particular computer system, right, where all data can travel, right? When you click a particular file in a particular hard drive, then the hard drive is connected to your system with some wire, right? Or maybe with a particular circuit. When you click on this, you can encrypt data on hard drive, but when data you are clicking, it has to be decrypted and then send out onto that wire, right? So don't you think there is a risk to data there, right? It can be on wire. It can be, once it is coming from hard drive, wire to your motherboard. On motherboard also, it has to travel to memory, it has to travel to CPU, or between CPU to RAM, or RAM to CPU. All that thing will happen, right? So that means it has to travel on bus as well. We call it as bus. The golden, you see, all that linings which you see on motherboard is all called as bus. And then within your CPU also, data is getting processed. There is some memory inside your CPU also. There are some general purpose registers, and there are some specific registers which are there. So that is also where we have data being processed, right? And then finally, data in use, when the data is getting processed, right? Getting processed within CPU. So how we can make sure that a particular hardware is making sure that data which is there into that circuitry part, right, inside your computer is secure, right? So for that, we have to think of something like when data is at rest. When data is at rest, then we have something called as TPM. What is this TPM? We'll talk about that in a while. We'll talk on that, right? So this is basically a
platform module.
Yeah, this is trusted platform module, which is embedded onto your motherboard by itself, right? So that is one way of keeping it safe. Another way of keeping it safe, maybe you need something as a portable device, which can manage your cryptographic keys and all that kind of thing. So that there is specific module which is called as hardware security module, right? Which will be a portable system, and you can take it outside the system as well to maintain your keys and all those kind of stuff, right? Then there are some drives which are coming, which are called as self-encrypting drive. That means you just have to write something on the drive, and the moment it is getting stored on the hard drive, it will be encrypted and then stored on the hard drive. So no need of a specific particular software and all, right? So these are few controls, you can say, we can implement when it comes to data at rest, to protect data at rest. When data is in motion, right? Data is in motion means it is very, very difficult to protect data. And the best strategy is when a particular CPU is sending data back to hard drive, right? Because it will be traveling through maybe bus, it may be traveling through RAM and all, right? What if we encrypt it here itself and then send to your hard drive? That is something which is called as bus encryption. Then when data is in use, right? For example, you have mobile device, and on your mobile device, you may have Google Pay, very common scenario, right? Or your company also allows you to access email through your work profile by enrolling your system into Intune, right? So this work profile itself, right, is getting hosted within a very secure zone, right? There is a kind of bubble which it creates, right? That is called as trusted execution environment. We call it as TEE, right? Then processors are supporting this kind of environment, right? That is also one thing. And the final one more thing is atomic execution. We'll understand what is atomic execution as well, right? So these are few topics which we are going to cover from a hardware perspective. Sorry. Make sense? Then we spoken about operating system, right? And here on your hardware level also lies your CPU. And here is your operating system. Your operating system is sending instructions to your CPU, right? That means your operating system, if your operating system is not secure, your hardware is secure, but your operating system is not secure, that can also land you in some kind of security problem, right? So we also need to understand how security is implemented here from a software perspective. And obviously on top, right, we have spoken about a lot of systems. We have spoken about embedded systems, IoTs, and those kind of stuff, right? We understood what are the security vulnerabilities and what how do we protect them. We have discussed that enough, like ICS and all that. So that is system specific, or you can say application specific security. So since we already discussed this part, now we are going to focus on this part and then on software and CPU perspective. Does it make some clear guidance what we are going to cover now? Because having this mind map is very, very important. Otherwise, you will not be able to relate it better. How it is going to help us, and how it is tying up between different things, right? With that said, let's go and discuss our first hardware device. Hardware security, you can say, or you can say hardware-based crypto systems. What is a crypto system? Which provides you all the cryptographic functions, right? We will understand more once we cover cryptography, right? So let's take the first part, which is called as TPM. Trusted Platform Module. Okay. So basically a TPM is a hardware chip. It is basically a hardware chip. Hardware chip means it has to be embedded on motherboard. Okay. The current version of TPM. What is the current version of TPM? Earlier this was 1.2, now it is 2.0. And unfortunately, this 2.0 is not that backward compatible and all that kind of stuff. So if you have an old hardware and you need to implement certain new encryption thing, then that particular encryption may not support the older systems. So you may have to refresh your systems, right? What does it has basically, this particular small chip, what does it has inside which help us to keep things secure? We call it as a cryptographic module, right? It has something which is called as microcontroller, which help us to keep things secure, right? Now, where we use and why we use TPM, right? We use TPM to store cryptographic keys, right? It can also be used to store digital certificates, right? It can also be stored to handle symmetric and asymmetric cryptography. Right? We will talk about those. What are those things, right? And it also has, like, for example, you have a TPM chip, and on top of your motherboard, you have an operating system, right? It will generate a particular, hash value of all hardware components and other things on top of it, and it will create a hash value of it. So if because of some malware or something, some configuration is getting changed in an unauthorized way, at every boot up, this will check, recalculate that hash value and compare this what the initial hash value was there, and it will let you know if something went bad. So in one way, it also provides you a protection against unauthorized access. Right? Any kind of malicious change, as I told you, right? This is a malicious change, right? Which can happen on your system. It is able to detect that, right? So every time your system is booting up, all the BIOS configuration, because there are BIOS based viruses also which are coming, right? And once when you switch on your system, right, a black screen comes, that is your BIOS. And then that BIOS actually takes you to the bootloader. Bootloader is the first sector into your hard drive, and that is where the bootloader file will be loaded into memory. And then there is a batch process wherein the kernel of the operating system and everything will be loaded into the memory, right? If there is a problem in there, there is a malicious thing, it will be detected based on the MAC, the hash value which the TPM generated, right? And then it will help you to understand if the system has been compromised. Then the most popular thing, right? The most what you and me knows, right? If your laptop or your security standard in your company says that all the laptops or desktops or servers has to be encrypted, because it may so happen that as an employee, you are traveling, and during travel somebody is able to steal your laptop and then take out your hard drive, put it into another system and copy all the data. Possible, right? To come out of that particular situation, right, there is something called as full disk encryption. There is something called as full disk encryption. So if TPM is not there, then those keys will be stored onto your operating system by itself, which is not good. Always we need to make sure that whatever you are encrypting, that key should not be stored on the same system. It has to be stored somewhere at a different place. So in a particular endpoint system, because you have to carry this, you have to travel all the time, that particular key has to be within the system, right? But at least what we are doing is we are not keeping the key on the operating system, versus we are keeping key onto a hardware thing, that is your TPM. We store it on TPM, right? And on TPM also, right? On TPM also, your key is not just stored like this. The key is further encrypted by key encrypting key. There will be another key, which will be like your manufacturer key and all, which will encrypt your existing password, key, or whatever like you generated during encrypting your hard drive. And that will then be stored onto your TPM chip. That means TPM has something into it. I've spoken about, right, what TPM contains. It has microcontroller, which will be doing all these cryptographic functions, which will be processing the cryptographic functions. Then there is some memory also, because we need to store something also, right? Keys need to be stored, where the hash value need to be stored. Where it will be stored? It will be stored onto your memory, onto random access memory. But this random access memory is not the same memory which you use as RAM into your system, because the normal RAM will need some electricity to refresh that particular charge to keep it updated. If you switch off your system, whatever is there in your RAM will go off. Then if you switch off the system, TPM also will switch off, right? So that means that is not the same RAM. We call it as NVRAM. That means non-volatile. This is a non-volatile RAM. That means if you restart your system also, the memory remains intact, right? And in this memory, there are two types of keys which are stored. So one is called as endorsement key, which is again a type of key wherein it will have public key also, it may have private key also. Private key is something which need to be very much protected, right? It has to come from your manufacturer by itself, right? So every time this private key will be used to verify the integrity of the TPM itself. First and foremost, you need to verify if my TPM itself is not compromised, right? So first and foremost, this private key will try to see if TPM has been compromised. If TPM has been compromised, then there has to be some mechanism to destroy some keys and all that, right? That means all your system has gone for a toss now. And if everything is okay, then the next part is checking the integrity of the hardware, checking the integrity of the bootloader and all those kind of stuff, right? So that is what is done by your endorsement key. The second type of key which is stored in the memory is called as storage root key. Saruk Khan, SRK, right? So this area will store your actual key, which is used for encrypting your hard disk drive. But it is not stored in a plain format. It is further encrypted by another key and then stored, right? It is something which is wrapped in another key and then stored, right? So that is what the level of security a particular TPM can give you on a particular system, right? Now, if there are some challenges as well, right, with TPM as well. If TPM fails or it has been tempered by somebody, will you be able to decrypt your hard drive?
No.
You can't decrypt, right? Can't decrypt hard drive. That means if it is done by mistake by one of your employee or by the IT help desk, then what will happen? Your entire data will be lost forever. That's not good, right? So in this case, what we need to think of is backing up the keys. How do we back up? For example, if you are implementing BitLocker as the encryption mechanism, right? That BitLocker also has a functionality of backup keys or master key. So if a system is going through this kind of, the TPM fails or some kind of tampering happens, then your IT help desk will back up, will restore the actual key. Right? Who will do it? IP help desk. So that is one good thing, right? You always need to make sure, even if you are using TPM, always take backup of your keys, or it's not that you are taking a backup of the key somewhere on a piece of paper or maybe an external drive. No, you need to take it centrally, wherein you are able to secure that. Right? Another challenge can be if the TPM is like your manufacturer itself. We understood, right? Your manufacturer give you some kind of public private key, which is very, very specific to a particular TPM module on a particular system, which is very, very unique. What if those keys are not, keys are not lengthy, or keys are not random, or there can be another case, right, wherein your manufacturer itself is compromised, right? It's a vulnerability with the manufacturer or vulnerability in TPM, let's say that simple terms. Then all those can be the security risk when it comes to TPM. Otherwise, if these things are taken care, TPM is the excellent way wherein a hardware module can give you all the protection when your data is like encrypted. Right? Any questions here, guys, before we go on to our next topic?
Sir, I
Yeah,
just want to understand. Sorry.
Yeah, good. Please go.
Thank you. Sir, could you please repeat that key part once again?
Okay.
Yes, scroll it down.
Just give me a second. Let me see. Let me stop recording, because otherwise recording will become very, very lengthy.
I think